In this video, I will be explaining the relationship between electric potential and electric field. To properly create a relatable analogy to electric field, we'll compare it to gravity. So we know gravity exists. We can only see its effects when we change the height of an object. Consider a slope or a hill. We know that when we place a ball on this slope or hill, we know that it has gravitational potential energy, because if we let the ball go, then it falls and gains kinetic energy equal to the potential energy it had at the height it was held. In a similar fashion, we can create an electric field by placing charged objects. So when we create this electrical field, it's like creating an electrical terrain that will affect a point charge placed inside. Usually point charges are positive. So we're going to talk about them with the assumption that they are positive, but opposite rules apply when they are negative. So large positive charges can be compared to tall hills. When we put a positively charged particle next to a large positive charge, the particle has high electric potential energy. So when we let go, per se, of the particle, it will gain kinetic energy and move away from the large positive charge in a similar way to a ball rolling down a hill. In the same way, when we place a positive charge far from a large negative charge, then the particle will gain kinetic energy as it is pulled in towards the negative charge, similar to as if the negative charge was a hole in the ground. It takes energy to move a positive particle away from a negative charge, like the same energy it takes to push a ball up out of a slope. So we can compare electric field to the terrain of a place, which changes in altitude that creates gradients of gravitational potential energy. With that understanding of electric field, we can talk a little bit more about electric potential. Electric potential is defined as the work per unit of charge required to move a charge from a reference point to a specified point. Basically means the work required to push or pull a charge along the terrain of an electric field. An electric potential difference can be compared with height. It has the same effect as on electrical potential energy as height does on gravitational potential energy. The smaller the change in electric potential, the smaller available electric potential energy exists, while a larger change in electric potential means that there's a larger electrical potential energy. So with that understanding, we can call electric potential difference voltage. The units for voltage are joules per coulomb. When we have a uniform electric field, we can use this equation to know the relationship between energy, voltage, and distance. The minus sign tells us that the energy points in the direction of decreasing potential. And just to reiterate, this equation only works for a uniform electric field. In a changing electric field, you have to use weird and confusing calculus that we don't have to learn for this class. So now we're going to do an example using that equation. So here we have a 0.005 kilogram particle that's positively charged inside a uniform electric field created by these two plates. The positive plate has a 15 volt charge, and this one has a 0 volt. So this field here is going to move the positive particle as if it was rolling down a slope towards the negative plate. So using our equation here of E equals negative delta V over delta S, we can calculate the energy to be 30. And using that energy, we know that potential energy plus kinetic energy equals the total energy. We also know that at this position that the positive particle is in, all of the energy is potential. And so potential energy at this point is going to be equal to kinetic energy at this point. So knowing that, we can calculate the kinetic energy of this particle at this point using the same energy we just calculated, which we got to be 30. So E equals 30. And now using the kinetic energy equation and the mass that we were given before, we can calculate this particle's speed and if we do all that math, then we find that at this point, this particle had a velocity of approximately 110 meters per second. I hope this video was helpful. Thank you for watching, and see ya.